But if you now have a well-endowed rocket and you put a lot of stuff in it, then it'll escape from the Earth. It might maybe perhaps go into an orbit around the Earth and never come back. Or with a huge charge, it'll escape completely from the solar system and go off and off and go on. And those are the three possibilities for the future of the universe, unless we've left out something that we don't know about that happens sort of after the launch.
Just to summarize, originally we had two theories. We had sort of a steady state theory of the universe going back 20, 30 years and a Big Bang theory, and pretty much the data has supported the Big Bang theory, in which things are not always the same in recreating and going out of existence, which was an older theory. Now we have the Big Bang. Now the question is, what happens there? And so we have to look at, will it all crunch together, will it fly apart? And if it does, are there other universes, or is there some omega point where it has some great universal meaning, or is there some theological implication to all of this? I think that is the totality of human understanding, I think, is involved with one thing or another. And let's, again, get back to some hard data. And the first place we should start is with the total amount of matter in the universe, since that is a prime factor. Wendy, speak to us about that.
Well, the question comes down to what Leon was just explaining. If we live in a low-density universe, then the universe
Low density means not a lot of matter.
Not a lot of matter. Then the universe will continue to expand forever. If we live in a high-density universe, then in theory you could halt the expansion and everything would come back to a big crunch. So people have been looking very hard for decades now to see how much matter there is in the universe. And early on in the 70s, when people were trying to pin this number down, what is the average density of matter, it seemed that there was not enough matter to halt the expansion. And people have continued to look, and...
When you look, what do you do? Density is the amount of matter in a volume.
Yeah, you can look on very different scales. So let me give you an example. In our own galaxy, for example, you can look and see how fast stars are moving around the outskirts of our own galaxy. And you would predict, if there's not much mass out in the outer part of the galaxy, that the velocity is going to fall off. It does that in the solar system. You see it in planetary motions. And what happened when people were able to make these sensitive measurements, they found that things were actually moving around really quickly in the outer parts,
which indicated more matter
than you could see. When you add up all the mass you can see, there isn't anywhere near, maybe 1% of this critical density that would allow you to escape.
So people then began to postulate new stuff. People
began to postulate matter that you can't see, dark matter, in other words. It doesn't emit light, but you infer its existence because of gravity and the motions that you see, what you can see.
So the thought maybe there's enough of that to make this critical density.
That's right. So that was the hope, that somehow you could achieve this critical density by this dark matter. And what you find is the larger scales you go to, the more of this dark matter there appears to be. So when you looked on the scale of our own galaxy and then clusters of galaxies like to cluster, you'd see more matter. So there was a hope, especially in the 1980s, that when you got to the largest scales, you could achieve this critical density. But that hasn't occurred. And what happened was maybe 30% of the universe could be composed of this dark matter. And
visible matter, everything altogether.
And visible matter,
everything altogether.
Visible matter is a small component of that, that's right. But there's an extra 70% or so that's unaccounted for if we have this critical density universe.
So what happens to that extra 70%, Andre?
Well, recent observations suggest that maybe it is in the form of cosmological constant, which is effectively vacuum energy density.
Okay, let's understand this.
Spooky matter.
Yeah.
The cosmological constant, did that originate with Einstein? He said that was his greatest mistake.
Yes,
he said that was his greatest mistake, was his, now maybe some people are saying it's his biggest, but for different reasons, a major success. What is that? That's something in his the equations, a cosmological constant he used to balance gravity, because he thought the world was a universe of steady state. Is that right?
That's right. He did his work before the expansion universe was discovered.
His equations clearly showed him the universe had to be expanding. He did not accept his equations, and so he put in a new force to make it the way he wanted it philosophically.
Which he thought the world was at that time, which was a steady state. So he put a cosmological constant to balance out gravity, to keep everything the same. All right, now what happened to the cosmological constant?
Well, later people tried to understand what is the interpretation of this cosmological constant. And the interpretation was that this is energy of empty space, just empty space, vacuum. It may still have some energy density hidden in it. And it is not forbidden by any laws of physics, so people try to measure it. Well, this is the first kind of measurement which we are coming close to in cosmology. We're trying to measure this energy of nothing, and it seems that it is not exactly zero.
People talk about this as if the universe has a spring to it. There's a springiness as well as a spookiness, a springiness to the universe.
If it were there, it would be pushing the universe apart faster and faster.
Right, and that's what the data shows.
But if you take the data that exists at the present time at face value, that's what you conclude.
And I might add, I'm very dubious that it should be taken at face value.
So we're working on the frontier, and we should stress that. These are very difficult measurements, and it will take a while before they're conclusively ruled in or out.
But yet people have said that this recent data is some of the most important breakthroughs that have occurred, which instead of showing what you were searching for, basically the expansion of the universe is slowing down because of gravity, slower and slower, it's actually getting faster and faster. Okay, so what I want to see, Nancy, is from your observation from a theological point of view, you see an infinitely growing universe, and you see a contracting universe which perhaps can give, at the last moment, consciousness or information so that things can happen. How do you view each view, and is a theological perspective compatible with either one?
Well, you started out by asking why should high school students or why should people in general care about all of this? Right. And what we're asking from a theological point of view is why should the human species care? And most of these scenarios are so far beyond what we could project for the longevity of Homo sapiens that it's irrelevant. So it's... But
it's not relevant to our concept of what we are and our purpose in life.
But I've argued that very near the final state will be brought back into existence. All of us, you and me.
So your point of view is in fact relevant to that question, but the more general questions that are raised in cosmology about whether the universe will be open and expanding or the Big Crunch or whatever is fairly irrelevant to the human species.
Oh, I disagree. I think it's irrelevant to what happens to us, but it's not irrelevant to what our purpose is and our self-understood purpose.
But if we simply cease to exist, simply go out of existence without any trace left of us, it doesn't really matter how that happens, does it?
Well, it matters now to how we, if that occurs, if we can see that occurring prior to whatever happens at the end, then sure. But how we conceive ourselves today, I think is very important to understand what may happen at the end. We're beings who can understand that. I think that's terribly relevant.
Well, yes, but that doesn't make it any more, that doesn't have any particular theological significance over and above what most of science does. But another way to look at it is, what does all of this look like from God's point of view? And again, I'm attracted...
I won't ask Frank, I want to ask you.
Thanks. Again, I'm attracted to Andre's conception of multiple universes because one would be tempted to ask if our little universe ceases to exist or ceases to have any life in it for God to interact with, what's God going to do for the rest of eternity?
That's unemployment.
Yes.
We want to avoid that at all costs.
That's right.
Social Security won't be around by then. Right.
But what bothers me about Andre's universe, it seems to be a resurrection of the steady state theory, in which on the largest possible scales nothing much happens, that everything is, so to speak, reproduced again. He's having universes being reproduced.
Andre, you've now had somebody say that your universe is terrific for God and somebody else saying it's just an old steady state. You're the man. What does it look like to you?
Well, first of all, I should perhaps take a more modest position, and I should not say that these are my universes. This is the standard prediction of the standard inflationary theory, which is widely accepted by many cosmologists who actually work in this field, and I'm not quite sure about the similar acceptance by many other theories which are under debate right now.
Nancy, the fact that cosmologists are even talking about things like the end of the universe, the beginning of the universe, these are things that theologians have talked about for many hundreds of years, if not thousands of years. Doesn't that excite you?
Yes, it does, because it gets people thinking about human destiny and, again, raises the sorts of questions that religion sets out to answer. But most of what's being said here is genuinely irrelevant to what Christians have been saying over the centuries, because they're talking about the way this whole universe, however the physicists describe it, is going to be transformed afterwards.
And that afterwards would occur when?
Well, that's not clear.